Hello, in this tutorial video we're going to look at designing stochastic lattices. So to start off with here, I've just imported a primitive cube, but this could be any model that you'd like to import into the system through the File Import tab. I'm then going to navigate to the Lattice panel, and on the right hand side here you can see three new types of lattice structure. We've got the stochastic lattice, and of course, as with the other lattices, we've got the option to shell and add a stochastic lattice inside your part, or we can offset the stochastic lattice from a surface. First of all, though, I'm just going to add a stochastic lattice component to this model. So to do that, I'll click on the model, and then I'll click the stochastic lattice button. And then this gives us a number of options. So first of all, we have the option to create a solid lattice. So this means that we'll have the lattice in its normal place rather than Booleaning subtraction. Again, as with the other lattice components, we've got the inverse option to create the negative space for the lattice, but we'll keep this off for now. And then up here we have the surface point and the surface density options. Now, these have a number of options inside here. We could choose vertices, centers. And this basically dictates the number of points that stick to the surface of our model. So to generate the stochastic lattice, I can press Update Struts. And by changing the options inside surface point and surface density, we can modify the number of points that stick to the surface of the imported models. If I decrease the slider bar, we get less points on the surface, and if I increase the slider bar, we get more points sticking to the, in this case, 6 edges of our cube. Inside point generation, we've got two different ways of generating the stochastic foam. We can use Poisson disk sampling, and then this then requires the minimum distance between each of the nodes inside of this cube. So the Poisson disk sampling essentially looks to evenly spread out these points throughout the volume that you want the lattice to be. Alternatively, we could randomly sample inside of the volume, and then you can then choose in this points box the number of points that you want. So at the moment there's 1,000. Soon there could be 3,000. And the number of points total will appear down here. And the number of struts total will also appear below, just above the add modifier component. The way that the points are then connected, you can choose in the connectivity method box. Here you can toggle between Voronoi, which is an algorithm for connecting up these structures, or you can choose a valence. So in this case, the valence will connect to the 5 closest points, or you can toggle the connectivity to be 4 closest points or 6 closest points. And this gives you your network of randomness inside the model. The seed you can modify. This just ensures that you get the same random points every time. So when you save your lattice and reload it, you get the same point. But you can toggle between the seeds and generate different random structures automatically. The strut diameter gives you, of course, the diameter of the strut. And then the scale offset allows you to increase the bounding box of the cube slightly. This is a percentage. So, for example, if you want better connectivity with structures around the bounding box, you might want to increase this by a few percentages. And as you can see, this then increases the bounding box, and your struts will move outside of the bounding box. But upon creation, these will Boolean back in, and you wouldn't see this. You wouldn't then see the struts moving outside of the of the bounding box. One thing we can also do is add a manufacturability constraint, and this just removes or prunes the lattice so that all of the struts are within a certain overhang angle and bridging distance, depending on what you want. So of course you can change that. You'll find that the lower the overhang angle, the less struts we get connected. But this can be a good way of ensuring you have manufacturability of your lattice structures if your structures start getting quite large. Once you're happy with the lattice structure, you can go into the Generate tab, set your resolution of your solve, and press Generate. Now this might take a few seconds, so I'll speed up this part of the video. And that will generate your stochastic lattice structure. And when you're happy with that, you can export that out of the software by decimating and clicking export current volume. And you can export that out in the same way as all of the other lattice structures.